Working with XML data. All right, XML, the extensible markup language. It has really taken off here in the past few years in the IT industry, and that's because it's a universal data format. It's a universal cross-platform data format, which is basically used to represent both structured and unstructured data. In other words, we can wrap relational data as XML. We can wrap flat data as XML, hierarchical data as XML. So it's really become wildly popular because it can support so many different types of data. And more importantly, it's easy to read, easy to use, easy to learn, and easy to understand. So we're gonna take a look at how SQL Server uses XML here, because now it supports it natively. We have our own XML data type that we can use to store data in, manipulate that data, work with it, so on and so forth. So let's start off here by taking a look at our outline. We're going to start off with an introduction to SQL XML, and here I'm just going to get you familiar with pretty much everything there is to know about XML, just a kind of XML in a nutshell. We'll analyze what it looks like. We'll talk about how SQL Server supports it, the new data type, and what it can do, and also take you through all the tools and technologies that we can use in SQL Server to query that data, manipulate that data, and just generally work with the data. So once we get a good handle here on how XML works in SQL Server, we're going to take a look at how to create and use some XML objects. Specifically here, we're going to take a look how to use that XML data type. Really, we're going to look at the columns, how to create XML columns, how to create XML variables, put data into those variables and columns. And we're also going to take a look at how to create what's called an XML schema collection. And really what that is taking an XSD schema, either existing one or creating one, and storing it in SQL Server so you can associate that schema with our objects, our variables, and our columns. And what that'll do is that'll end up creating what's called a typed column or a typed variable. And we'll talk about all these things here in our introduction. Once we get familiar with how to use these XML objects, both the data type and schemas, we'll then move on down to working with XML data. And here we're going to learn about all the different ways we can work with, query, manipulate, and use XML data in SQL Server. There's a lot of different tools and technologies we can use to manipulate XML data, and there's a lot of things that SQL Server natively supports for us to work with this XML data too. Specifically here, we're going to take a look at XML DML, how we can manipulate XML data using the brand new XML DML statements on top of this XML data type. We'll then take a look at how to use generate XML, really, using the for XML clause. And for XML, we can use in our select statements. It's been around in the past. It's been a little bit enhanced in this version, but we'll take a look how to use it nonetheless. We'll also take a look at how to use the for XML statement. And this is really talking about, again, querying, another method of querying XML data. So we'll get familiar with for XML and open XML. And at the end here, I just want to talk about XML indexes. I'll show you how we can create an index on an XML column, and also just why we would want an XML index in the first place. All right, let's jump right into it here and get familiar with an introduction to XML here, starting with our overview. What is XML? Again, XML is kind of a universal human-readable data format that took off a few years ago. And the reason it took off is because it's human-readable. We can read this data format. It's easy to understand. You can express a lot of different data formats inside of XML. For instance, here I have a little sample of an XML segment. And really, there's two forms of XML in SQL Server. You're going to hear it called either fragments or documents. Of course, a document just means it's XML with a root node, where a fragment would be something like this right here. This would be an XML fragment. We wouldn't have a root node under here, products. We just have a product, where this could be considered an entire XML document simply because we do have a root node, products. We can have multiple products underneath, multiple product entries underneath our products node here. So basically, again, how this works is it's kind of stored. XML is a hierarchical format. You can see here we have nodes. They go from topmost, the parent level, all the way down to these child levels in here. And they consist of elements and attributes. Elements are these guys right here, where you have the brackets, open, close. This would be kind of an element here. Attributes are these right here, where they're enclosed. Their values are enclosed in quotations, and they're wrapped within an element. Now let's take this XML here and break it down a little bit further. Just by looking at this, I can kind of tell what the table structure would look like if this was expressed as a relational database. And here's how it would work. You can see on the outside here we have products. This is obviously a product listing, so we'd probably have a products table somewhere. Right, so this could be our products table. And then if you look down here, we have another a child element down here with other elements here called components. So I could say, all right, products are associated with components. Products have components here, so I could probably have another table called components, right? This would be our components table. Now how this would work here, as you can see, it would be a one-to-many relationship here because our our components are a child element of our product. So one product can have many components. So this would be a one-to-many relationship here between our products and our components table. And that's pretty much how this would be broken down to. We'd have more products underneath here with more components. So we'd have a record in a products table for each product, and then we may have multiple records for all of the components that are associated with our products. But that's the nice thing about XML. You can just, it's really, by looking at it, once you get familiar with how XML looks and how it works, you can just tell where your elements are and how they map to the table structure underneath the hood if it were to be expressed as a database. Now again, this is very, very bare bones basic XML here, but XML is not that complicated. There's not a lot to it. There are some advanced things you can do with it, but once you get familiar with how the basics work, even the advanced stuff comes pretty easy. So onto the XML data type here. Again, we can store entire documents in XML columns within our tables, or just XML fragments. And either one of those can be up to 2 gigabytes in size per row. So we have plenty of space available to store our XML fragments and documents. Also here, as I mentioned earlier, and we're going to be using them, we can be associated with columns, this data type, variables, and parameters. They can be typed or untyped. Typed just simply means that we have an XML document or fragment associated with a schema, an XSD schema. And an XSD schema is just basically when you associate a schema with a document, you're specifying all of the data types for all of these variables and other rules associated with it, all of these elements and other rules associated with it, such as how many times can it be listed, what order, does it have to be in a specific order. So it's really the rules associated with how this XML, how the data can be stored, and also how the data looks, so on and so forth. So XSDs are good because having them typed and having an XSD associated with your XML means it's safe. You can have validation that occurs prior to the XML coming into your variables and your columns, and it's just very safe. Where untyped is not associated with any form of a schema, and it's just free-form XML. Nothing's checked. Errors can happen. XML formatting gone bad can absolutely occur. And then finally here, the XML data type can be indexed, and you can have 2 types of indexes, a primary XML index and a secondary XML index. And you actually, if you're going to have secondary XML indexes, you have to have a primary XML index. And also, if you're going to use an XML index at all, you have to have at least one clustered index on your table. So we'll talk about, once we get into our demo here, I'll show you exactly when is a proper place to use a primary index and what it's good for. And of course, if you're going to have any secondary indexes, why you would want them. And it really all comes down to your data access. How are you accessing this data? What technologies are you using to access it? That's really going to determine the type of index you put on your XML data types. Now we have many, many, many ways of accessing and manipulating and working with this XML data. I'm going to get you familiar with just the basics of each one of them. We have XML data type methods. On the XML data type, we actually have methods built right on them. So this is kind of new to any type of data type in SQL Server, because we can just do column name dot method name, and then inside of the method it would take an expression, and we'll talk about those expressions here coming up. But basically, this is a very easy way to work with XML data itself, because there's a couple of different methods. There's, for instance, the query method if we want to pull XML data out of it. There's a value method if we want to pull a specific value out of an element or an attribute. We can use one of those methods. And there are actually many. There's a modify method. And the modify method is kind of interesting because it plays right into this next one, XML DML. We have to use that modify method on here if we're going to use XML DML. And XML DML is just like SQL DML, where SQL DML we have select, insert, update, delete, where XML DML we just simply have insert, delete, and replace. So kind of the same thing, just replace instead of update. And again, we use XML DML to manipulate the XML and change the XML and work with the actual XML data type within our columns. We also have xQuery, and this kind of plays right in, these methods play right into xQuery. xQuery is its own little language. It's considered an expression language or a path language. It's based on an old technology called XPath, and really what we do is we use xQuery to kind of navigate the nodes inside of an XML document to extract and filter specific data. Now, xQuery is also a very robust language. There's a lot you can do with it. We really could dedicate an entire series just to xQuery because it is rather large. The cool thing about xQuery is the basics are kind of like the basics of navigating any hierarchical structure. Take the directory structure of Windows. You want to get to a specific folder, you're going to have to go, C:\\/ folder name / folder name. you're navigating a hierarchical structure. And that's what we're doing with XML too. You can see we're navigating a hierarchical structure. The difference is with xQuery, there's so much more we can do because we may want to update certain data if it's this day at this time when it's snowing outside. So I mean, just because we're talking about updating a lot of data here, we're not really just navigating a directory structure. There is a lot more we can do with it. But know that xQuery, getting the basics, very easy to understand, especially if you're familiar with navigating a directory structure in Windows. Some of the advanced stuff does get a little tricky to get the hang of, but like anything can be learned with enough practice. So, xQuery, definitely, if you're going to be heavily using XML, I'd suggest getting very familiar with xQuery because the more you know, the more powerful you can get with xQuery and do quite a bit of cool things. But just know that most of the ways we access data using all of these XML technologies are going to require an xQuery to get at that data. So it's a good language to understand simply because it's used everywhere, and not just in SQL Server, but other languages as well. If you're going to get familiar at all with the .NET language or anything in the .NET framework, accessing that XML also takes a lot of xQueries and a lot of xQuery expressions to get at the data. Now, we also have SQL Server XML statements. These are built into the Transact SQL Server language. On the select statement, we can do a for XML, and a for XML is a great way to actually generate XML based on data in SQL Server. So we can pull our standard old tabular data out and format it as XML using the for XML statement. We also have OpenXML, and OpenXML allows us to basically return XML data as a tabular format, so back into the SQL Server version of how data is stored. And we do this, we actually use this in the from clause, and we can open XML from a document, from a variable that has XML in it, whatever you can really think of here. But basically, it's just a way to take data out of an XML structure and bring it back into a tabular format. And this also actually uses xQuery. So pretty much everything here uses an xQuery expression to pull data out of XML, except for XML here, because this is a way of generating XML data from tabular data. So we have lots of different ways here to work with XML data. I'm going to get you familiar with every single one of these, and we'll take a brief demo on how to use every single one of these methods to manipulate and work with XML data. Alright, so let's head on into SQL Server Management Studio here and get familiar with how to work with XML in SQL Server and also use some of these technologies to manipulate XML data. So let's head on down to the Start button, up to Programs, over to SQL Server 2005, and right down to SQL Server Management Studio. We're going to connect right into our production instance over there in our SQL Nugget machine. We'll have an Object Explorer connection here. We're also going to open up a script that I put together here by going to the File menu, Open menu, and then File once again. And this time I'm going to open up our Using XML script here. And we're also going to connect this script up to our same server over there, our production server, and choose the AdventureWorks database. That's the database we're going to be using to test out and work with all of these XML objects. So again, the big part about XML here and where we're going to be using XML is both in our tables. We're going to create columns as an XML data type here, so we can fit XML into these columns within our tables. We'll also use variables as XML, so we can of course put data into these variables if we're going to use anything on those variables before we put them into our tables, or just generally to manipulate data. And also here I'll show you how to put data into those tables a couple of ways, using the variable as we're going to store XML inside of a variable, and also as a string. Say we just have a bunch of data as a long string here, and we want to convert that data to XML before storing it into our table. So we'll talk about these three things. We're first going to start off here with untyped XML columns. So untyped again means it does not have an associated schema attached to our columns or our variables here. And first up here, creating a table, creating an XML column in code is pretty much the same way as creating any other column in code, an integer column or a character column. Just simply say the column name followed by the keyword XML here, so we'll know that it's an XML data type. Same with creating it through the interface. If you're going to create, or modify a table in the interface, and you want it to create it as XML, you just name your column and choose XML out of the pick box, and that'll give you it. And how it looks here inside of Object Explorer, let me find one here. I think we have Store. Store has an XML column in it, I believe. There it is, the demographics. See, stores have demographic data, which is really just a survey. You can see here it has XML. And this is actually a typed XML column because in parentheses it has the schema associated with that column. Otherwise it would look just like date times. It's just XML and then null or not null. So that's kind of the only difference here between the XML data type and other ones is since we can have a schema associated with it, it may look a little bit different inside of the interface because you'll have the schema attached to it. Other than that, it's just another data type. Another data type that we can use to put data into and work with in SQL Server. So setting up an XML data type column, pretty much the same as setting up any other data type column. The only difference again being that schema. We can associate a schema with an XML column. And again, I'll show you how to do that here shortly when we talk about typed XML objects. Now, data types are, variables, pretty much the same thing. Declare variable name, XML data type, works the same way. You can put data right into your untyped variables. The only thing that SQL Server does do on untyped variables for us is your XML here has to be well formed. In other words, if I take an end tag off of here and try to put this data inside of our variable, it's going to yell at us and say, sorry, but that's not very well formed. It's missing the close bracket here. So that is a plus. Other than that, you can pretty much put XML data at will into these variables. Again, 2 gigabytes is the limit on the size that can be fit inside of these. But that's it. Variable, same thing. Also here, if we want to put data into tables, very simple, just like putting any other type of data in tables. We can put them in based on a variable. We can put them in here as what I'm doing here is actually as a long string here. Typed out as a long string, and then I'm casting it as XML. So you can absolutely cast and convert data to XML, to the XML data type, no problem. I'm going to actually do all 3 statements here at once. We're going to create the table, declare the variable, put the data into it, and then put the variable data into our table, and then also our string data into our table. So we'll highlight all this code, hit execute. There we go. So it should have created our table with our XML data type column. Let's go ahead and refresh our table node over here. You can see we should have our dbo.test table. There it is. If we expand this, look at the columns. There we are. And you can see test ID, here's our XML column, and there you go. You can see we don't have a schema associated with it, as you can tell here. And that's it. Now we have a simple table. We also have rows in here. We have these 2 rows that we put in. So if we do a select star from test table, we'll highlight this, hit execute, and check it out. Now this is another really nice feature I like about XML in SQL Server 2005 is rather than before where I had to scroll and look inside of here at all this data and try to figure out what elements belong to what elements, a pain in the tushy. So now we can just simply click on it. Watch this. Look at that. It starts open its own tab here as an XML document, and boom. We now have a nice structured view of our XML, and it's even color-coded for us. Look at that. Pretty nice, huh? SQL Server can now recognize that this is an actual XML document and show it to us like it's an XML document. So a big plus there of working with XML. It makes it really easy to develop with your XML data, test your XML data, look at the output, and so on and so forth. So pretty cool stuff here. All right, let's move on to typed XML objects. Again, typed XML just simply means that we have our columns here and our variables of XML data type, we have them associated with a schema. And again, a schema, what that does for us, if you tie a schema to an XML document, it really just a greater level of validation. We can have all kinds of rules in that schema that says, you know, this age data type or this age element, it has to be an integer data type. It can't be anything but an integer data type. So, of course, whenever we try to put data into this variable or column or whatever, that schema will validate this data coming in and say, all right, is an integer data type. If it's not, it'll spit out an error to the user. So, and there's lots of things you can do. You can, you know, the number of times this element can occur, the order in which it occurs within this document if you want, you know, your ordering to match up, and many, many, many other things. But really the main purpose is data types. That's really the most important, and that's why it's called typed. And again, if we're, the first thing we're going to do, is if we're going to create typed objects and typed XML variables and columns inside of our databases, then we need to have schemas. And we need to have these schemas inside of SQL Server so we can do that. So the first thing we're going to do here is learn how to import what's called an XML schema collection into our SQL Server database here. So I actually have another script that I'm going to open up here. We're going to head to File, Open File, and I'm going to open up our XML schema collection script here and connect this right into our prod database and also our prod server and connect this into our AdventureWorks database. Now, there are lots of different ways to create schemas, and there are tons and tons of different tools and technologies out there that'll assist us in creating these schemas. My personal favorite is Visual Studio. Both 2003 and Visual Studio 2005 have a schema designer in there, so you can just simply use the graphical utility here to create your schemas and create your columns and associate data types with them and put some rules on them. Again, very, very simple to use. I would suggest doing that. And the nice thing about Visual Studio too is you can create your schema and then you can flip over to the code to actually see exactly what it's writing as you do it. So it's really easy to create these schemas. Again, use the graphical designer, and then you'll get familiar with the code just by looking at the code every time you do something. And it's actually pretty easy to read here. We're going to create a person.demographic table, and it's going to link right into the AdventureWorks database here and link into all these other person tables. It's basically just going to store general demographic information about a person. So what I did here was I just created a very simple schema that had trapped some of this information, the age of the individual, if they're a homeowner or not. You can see age is an integer data type here. Homeowner is a Boolean, true or false. A job title, the company they work for. Location, you can see the location here I did something a little different with. I created an enumeration, meaning that this isn't your standard data type here. It's actually, it has to be one of these data types down here of the location data type. And basically, location has to be north, south, northeast, northwest, southeast, or southwest. If it's anything other than these, if the user tries to store data and it doesn't have one of these as this element, then our schema here is going to throw a validation error, and the user is going to see something like the location has the wrong data for its data type. So pretty cool stuff here. Again, very easy to use schemas. But again, if you do use schemas, you know that your data is always going to be the way that you intend it to be and structured, the way you defined it in your XSD schema. But again here, very simple schema to here. All I did was created it in Visual Studio. I went into the code, copied the code, and then just pasted it here as a string. And the create XML schema collection statement works just like that. Create XML schema collection followed by the name of your schema. We're going to call this the person.demographic schema collection, followed by the as keyword, and then just a string, which is of course the definition of your XSD schema. So if we highlight all of this code here and hit execute, boom, it's going to say commands completed successfully, and now we have a schema stored within our database. And if you want to view the schema, the actual definition of it here, you can do a select and then this special keyword here, a special function called XML underscore schema underscore namespace. And what you do is you pass in the namespace, the schema namespace. You can see up here we did person, followed by the name of the schema. So person.demographic schema collection. If you highlight this, check it out. Here's our schema. We click on it. Now we get it all nice and formatted just like XML. And here it is. There's our schema, everything about it. So pretty cool stuff here, pretty easy to use. Creating these schemas, importing them in SQL Server has never been easier. If you want to delete a schema, same thing. Just drop followed by XML schema collection, followed by the name of your schema. Also, if you want to see all the schemas in your database, what you can do here is you can do a select star from sys.xml underscore schema underscore collections. You can see this is actually a system view here that we can use, what they call a catalog view. So if we highlight all that code and hit execute, check it out here, all of the schemas within our database. So these are all the AdventureWorks schemas, and they just show you the name, the date they were created, and modified, if at all. And what you can do then is you can pass these in to these statements and find out, of course, the actual definition of them. So great way just to see all the different schemas available to you in your database that you've imported. But now we have a schema imported. Now we can tie it to our columns and our variables of the XML data type. So now let's create our person.demographic data table here. And basically what we have is we have our contact ID column as a primary key, so we can link back into all of our other person tables. And we also have our demographics column here as an XML column. And here is where we're associating our column with the schema. We just wrap it in parentheses after our XML data type declaration. We're going to say person.demographic schema collection. Now anything that comes into this demographic column will be validated against that schema to make sure that all our data types match up and any other rules associated with it match up. So let's go ahead, highlight this code, and create our table here. There we go. Commands completed successfully. Now if we right-click on our tables here, hit refresh, and head on down to our person.demographic table, take a look at the columns. There's our demographics XML column, and you can see that it is associated with a demographic schema here, as you can see. So now that we have our column set up, now we can start putting data into it, and you can see here, variable, same thing. If we're going to declare variables and we want this variable to match, of course, a column because we're going to put the data into it here, we're going to associate it with our schema. And then we're going to just set data, set our variable here equal to some XML data. And of course, all of this data will match that column. Actually, let's go ahead and change our homeowner here from 1 to, let's say, false, right? Because this is technically going to be read as a string and not a Boolean value. So if we try to do this and hit execute, look at that, invalid simple type, false. So it kind of tells us here exactly where. And this is returning back to us an X query saying that this element, navigating the structure here through the person demographic homeowner element is invalid for its data type. So if we change this back to 1 here and highlight all of this and hit execute, commands completed successfully. That's good. That just basically means that it fit the data into this variable and that it was validated against the schema successfully. And now everything down here we're doing is pretty much the same thing. We're just storing data based on the variable into our table, and then below that same thing, just converting a string to XML. Only down here I'm using convert, where up here I used cast. So two of the same, pretty much the same thing, just they function a little bit differently. But we're just converting a string to an XML data type. So let's highlight all of this code, hit execute. We got our 2 rows in there. Now if we select star from our person.demographic data table here, we should have all of that XML stored in 2 rows. Here's our first one. There it is. Look at that. Person demographic data, the age, the homeowner, the location. And it's kind of funny that it actually turns it back to true, false on its own. I like how that works. You can't type in true, but it'll do it for you. And then here's our second one here. And there we go. This one also has the location in there as a valid location. And you can see that's it. That's pretty much it. The typed XML, it's just associated with the schema, and then that schema validates the data coming in every time that the data does come into our variable or our tables that have an XML data type. All right, let's take a look at how we can manipulate and work with XML data directly right out of our actual columns within our tables here. And the first thing I'm going to show you how to do here is work with XML data type methods. We have a couple of very powerful methods that we can use to directly extract specific data, specific XML data, out of the XML structure. So the first one, again, I'm going to show you here is working with our test table. Let me just go back up to this query here and grab everything from our test table. What we're going to attempt to do with this query here, the query method on the data type, is let's say we just wanted to grab all the components. We wanted to extract the components section out of all of our columns here. So you can see we have a couple of rows here, product ID 1 and product ID 2. Let's say we wanted to extract the components section out of both of these. How would we do that? Well, the perfect way to do this would be to use our query method, and scroll back down here, our query method on the XML data type. And this is going to accept an XQuery expression that we can do this with. And basically what we're going to do is we're going to build our XML while extracting XML at the same time. So we're kind of dynamically building XML here. So we do a select column name dot query followed by our expression. What this expression is doing is, the first thing we're doing here is we're just outputting. This is output. We're going to output product components. We're going to output product ID all the way up to here, up to this open quotation mark here. This is an XQuery inside of brackets right here. We're saying extract first the product ID, and we're going to extract an attribute. You use the ampersand here, the @ sign here, to extract any attributes out of XML. So the first thing we're going to do is we're going to go through the product info node, and just to show you here, let me open that up again and leave that open. There we go. We want to extract this out of here first, so we're going to grab anything that's a product ID right out of there and store that here as a product ID. And then we're going to close the bracket, close the open parenthesis here, and the next thing we're going to do is just extract all the components section out. So you can see we're kind of navigating here. We're saying product info / components. And what that's going to do is it's going to go through the product info node and then hit this node, and it's going to bring all of this back to us. So that should be the result then, and then of course end it manually here by adding our own product components tag at the end. So if we highlight all this and hit execute, and we click on one of these, well, let's compare the two. Here's our original. Here's what it looks like. Product info, product ID = 2, and then all the standard elements, and then our components elements. Then, of course, the description element at the end here. What we did is we just wanted to strip out the components section. That's exactly what we did here. We just stripped out the components, and we added our own tags up here. Product components. We specified product ID equals, and then the value here. And this value right here was extracted through this XQuery right down here. Right there. That's where that value came from. So we just basically used XQuery along with some static strings here to dynamically build the results, which is our XML. And that's how you can use a query method, just to extract specific pieces of XML out of our XML columns. Now we also have an exist method, and the exist method is great when you just want to test if an element exists or not, because again, in our XML example, we have optional. Everything's an optional element. So they can store a job title in one, but not a job title in another. So this is a great candidate for the exist method because you can, again, test if certain things exist here. And we're going to use this in our typed XML just to show you how to kind of work with typed XML, especially when you have namespaces involved, because you can have multiple, when your XML gets really complex and you have a lot of data, a lot of complex structures, you use namespaces to split out what belongs to where. And so we use a namespace here. So basically what you have to do is you have to declare your namespace, give it a kind of an identifier that you can use then within your X query to extract specific data, navigating through the correct namespace. And namespaces are good. Say we have, multiple job titles. Well, if you have 3 different types of job titles in one XML document, that's a great way to set up a namespace there, so you can tell which job title belongs to which data structure. But back to our goal here of defining exist. Again, we're just using this in the where clause this time. We're doing where our table dot columns dot exist, and we're going to say where the job title exists. If this element job title exists, pull back that record. And just to again show you here the output, let me go ahead and highlight all of this code. Hit execute, and you can see we only have one out of both of those records in there. Only one of them actually has a job title in them. And just to show you here, let me scroll back up to our person.demographic data and hit execute. You can see that our first one didn't have a job title in it. We just had age, homeowner, and location. So we know that our first record should not come back. And of course, when I highlighted this here and hit execute, the first one did not come back, only the second one did. And this one does have a job title in it. So again, just kind of show you what this code does here. First thing we do is we declare the namespace. We wrap that into the PD here for person demographics, and then we're just navigating our structure through the namespace, PD colon, and then the name of our actual XML root element here, person demographic, / PD colon job title equals 1. Equals 1 meaning true, it does exist. Otherwise, if you wanted to test if it didn't exist, you could hit 0, in which case we'll get our other record back, the first one rather than the second one. So exist, again, a great method to use. Pass in an X query here, and then you can use exist to test if certain elements exist. All right, the next method we're going to look at here is the modify method. But in order to use the modify method, we need to know how to use XML DML, because the modify method really it uses quite a bit of things here. It uses both XML DML and XQuery to modify any raw XML data. So what we're going to do here, we're going to create an untyped XML variable. We're going to put a bunch of raw XML in here, just the product info that we used earlier. And then we're going to use the modify statement a few times. We're going to learn how to insert an element in here. We're going to insert our own component inside of the components section here. We're also going to insert an attribute in here, show you how to use XML DML to insert an attribute. And then we're also going to remove an element. So show you how to do a few things here with the modify statement. So that's what we do. We create a variable here. We put some raw XML data into the variable. And then we use the modify method here on the variable. Again, you can use it on anything that's an XML data type. It doesn't have to be a column. And that's what I'm doing here, using it right on the variable, XML data.modify. And we're passing in a XML DML statement. Again, we have the insert keyword here. We're saying insert this element, seats. And again, this doesn't have to be static XML. This can also be an X query if you want to pull it from somewhere else here. Same with the value. You can pull the value from somewhere else as well. But we're saying insert this static seats element into, and then we're using an X query. And again, in this sense, we have to use, we're using the actual open brackets, close brackets, or excuse me, open parenthesis, close parenthesis here to denounce that we want to insert this into the components section here within our XML, the components section. There it is. And now this here at the end here, this is actually required, the ordinal here. Basically, where is it going? If we have 4, product info records, how is it going to know which component section to put it in here? So since we only have one, the only, of course, valid value is 1. But that's what this is. Where does it go in the position of the XML? If you have 4 records, which one is it? So that's all we're doing here. So now if we highlight all of this, we're going to declare that variable, put that original data into it, then we're going to modify and put our own into it. And then what should come out is this plus the seats element. So let's go ahead and hit execute here. Let's go ahead, click on our code, and look at that. There it is. Seats got put in there using the modify method and some XML DML. Now we can also insert an attribute into our raw XML data here. And how this works is you just do an insert followed by the keyword here attribute followed by the name of the attribute and then the value of the attribute here within curly brackets. And then where you're going to insert it into, well, that's where you choose the into, and then our X query here to say we want to insert it into the root product info node at the very first position. So that's all we're doing there. Let's go ahead and comment out this code by highlighting it. Hit comment out so we don't get to see our code that we just ran. And now let's highlight all of this, hit execute, pop open our XML document here and check it out. So there it is, our product name, the name of our product here, just like so. Pretty easy to do that using the insert into. The only difference is it's an attribute rather than an element, so you have to specify your attribute. And then of course it works just a little bit differently because you're specifying the name. You don't actually have to specify in this bracket stuff because it's an attribute, and then the value has to be wrapped in brackets here. But that's it. And then if you want to remove an attribute here, you just use the delete command with the modify method. Delete, and then your xquery to go ahead and say which node would you like to delete here. And in this case here, we may want to put a 1 as well, because if we didn't, we would remove all of the product names. But that's what we would want to do, because in this case, we were actually going to move this product name as an attribute, and then after we move it, we delete it as an element. So I'm just going to comment out this specific one here so you can see the final result. We'll highlight all this, hit execute, and there's the result. We actually added our product name as an attribute and deleted it as an element. So there's a lot you can do with sql.dml, and there's also a replace statement. If you want to do any updates on the actual data, you can use the modify method with the replace statement, and it works again just like sql.dml. We're manipulating data here. You're manipulating XML data rather than SQL data, although everything pretty much works the same, so it's very easy to pick up. Again, it's just getting familiar with how xquery works, so you navigate and delete and insert on specific nodes. All right, now let's take a look at the transact SQL statements that we can use to generate XML. We're going to start here with the for XML clause, and for XML does that. It takes relational data, data in our tabular format within our tables, and using just a standard query, we can return the data as XML. So how this works, though, the for XML clause, it's just appended at the very, very end of your query. You do a for XML followed by the mode. And the mode is going to really determine the shape of XML, how it's going to look when it comes back to us. The simplest of these modes is raw mode. And just to show you here, I'm going to, very simple query, just grabbing a product listing out of the products table, product ID, name, product number, and color. And at the end here, we're going to do a for XML, and then we're going to have raw as the mode here. And I'm going to hit execute, and here's our results. And you can see very, very generic. We have just a static row element, or a node here, and inside of this element is actually just a bunch of attributes. So everything comes back as an attribute, and it's a very generic row element here as they all come back. So again, not a lot of control over how that looks. We can have a little more control by adding the elements option on the end of this, and this will just basically turn all of those attributes into elements. And again, it looks a little bit better, but again, it's still generic. You still have just a generic old row element as your root element for each one of your products here. So raw mode, very simple, easy to use. We don't have any control really over the shape. It's either attributes or elements. Auto mode, we have a little bit more control over the shape, and it's really going to be dependent upon your query. So we have a little control over this by, for instance, we have a join here. So our customer table is going to be our base table, and then we're going to join it to the sales order table. And just to show you how this looks like here, this again grabs customer's order, so a customer and their orders here. And we're going to do a for XML auto this time. So, and this will bring back quite a bit of data here, so we'll give it a second. Not too bad. Here's how it works. We have our customer, right? Our customer with our customer ID as elements here, customer information as elements. And then our sales order, again, was a join on this table, so we know it's a one-to-many customer to orders. So we'll have all the other sales orders underneath the customer here. And you can see, again, we don't have as much, we have more control as we do when we use raw mode, but auto mode still lacks in the control department as far as how this XML is going to look. At least we don't have the generic row element. It names this customer root element based on the customer table, sales order based on the sales order table. So that's nice. We can, again, have a little more control here if we add the elements option at the end of this. It'll then be a little more formatted, a little more user-friendly rather than just everything as attributes. So same thing here. I just ran this query, only this time with the elements on it. You can see a little nicer, a little more shape. We have customer up here, customer ID, customer type, and then all the sales information for all the sales orders underneath that customer. So a little bit more control in auto mode, but still not as much as we could have. Now, if you do want that full control over the shape of your XML to really maximize how your XML is formatted, then the other two modes, of course, they're the most complex modes to use, is explicit mode and path mode. Again, explicit mode, it's not that it's complex to use, it's just cumbersome to use because you're going to be doing a lot of naming of your columns a specific way. Path mode is the most complex to use. You have to again use X queries quite a bit, and there's a lot of other things you have to use as well. But again, because of the complexity, you get full control over the shape of your XML. You can really get it to pretty much do anything you want. You get it to look any way you want it to look. But I would look into those. Also, one thing I want to show you that's pretty cool, I was talking about generating XSD schemas earlier using tools. You can actually use 4XML mode to generate XSD schemas, and they're called inline schemas because they're going to get returned with the data. And what you do here is all you have to do is type in XML schema as an option here. And you can only use this on auto and raw mode here. You can't use it on explicit or path. Basically what this will do for us, if we highlight this and hit execute, it's going to return us with the results a schema, an XSD schema. So what we can basically use to strongly type our variables and our columns. And look at this. Doesn't this look familiar? It's actually going into SQL, grabbing their specific types here, and it's even putting them in, because we have a nested one here, it's even showing us that the sales order are underneath our customers. So pretty cool stuff here. And you can see everything below this last schema tag here is the actual data itself. So if you want to auto-generate a schema using SQL, we can do that too. So pretty cool stuff here. Now we also have the OpenXML statement, and this works kind of the opposite of 4XML. What OpenXML does is it opens up XML and it returns it back as a tabular format. So we can pretty much query any XML structure here, extract data out of it, and return it back as a tabular format, as we see when we open up tables. Basically, it looks just like a table. So how this works is a lot different too than other ways of doing things. It's a little older style. OpenXML has been around for a while. What we need to do is we need two variables. We need an integer variable here, and we need a character variable. I'll explain what the integer variable does in a second. The character variable, of course, just stores the XML data. The first thing we need to do once we get these variables declared and our XML data ready, prepared to send into the system store procedure, we call the system store procedure sp_xml_prepare document. We pass in our integer variable as an output parameter, and then our XML data with, of course, all of our XML here as its parameter. And basically what this guy does is this loads up all of this XML into memory, and then it returns back to us an integer variable, an integer value here that is a pointer, or a handle as they call that, to the in-memory structure that is this XML data. And basically what that does is it prepares it for the OpenXML, because now the OpenXML can run, because what it accepts is a handle being the integer from this prepare document. It also accepts an X query here, an XPath query that will allow us to extract specific data. And at the end here there's a flag, and this flag can be either 1 or 2 or 0, I believe, or maybe it's 3. But this just determines if it's going to come back as elements, if they're going to come back as attributes, basically what you're extracting out of these specific nodes here. And we're going to actually take out the attributes here out of the customer node. That's what we're saying here. Return us the customer node and the attributes of that customer node. You could do the elements of the customer node too here by specifying a 2. And then we do a width. And the width is just going to determine, we're basically just going to set up our columns, what the name of our columns are, the data types that they are, and then they'll get sequentially thrown into here. So we'll get customer ID in here, and we'll get name in here. And at the very end, what we want to do is we want to remove that document from memory. Of course, we don't just leave it sitting out there. So we do an sp_xml_remove document, and again, pass it in that handle so it knows where to find it in memory, and it takes it out of memory. So we're just going to, again, the whole thing here is we're just taking out the customers, in this case, the customer attributes, and bringing them back in a tabular format. So let's go ahead and highlight all this data, all this code, and hit execute, and check it out. There it goes. Customer ID 1, John Doe, 2, Jane Smith, and that's exactly what we extracted out of there. So OpenXML it does. You look at it a few times, you go, what? That's not the standard way of doing things. And that's because it's a little old-fashioned, because it's been around for a while. But it's still there. It's still an option, and it's still not bad. Once you get the hang of doing this, it's actually pretty easy to extract data out of XML and return it as a tabular format. So you can see there's a lot of different ways to work with XML data, whether you're manipulating data, querying the data, returning regular data as XML, returning XML data as regular data. A lot of different ways to work with it in SQL Server, and that's a good thing. It's a good thing that we have so many options when it comes to dealing with this kind of stuff, because in the past, we really didn't have a lot of things, a lot of ways to work with XML data, and we had to do a lot of this manual stuff in order to do anything. But now we do, and that's kind of what my goal here with this video is to get you familiar with just a little taste of each one of those ways of doing things. So the last thing I want to show you here is XML indexes. And of course, XML indexes work the same as regular old indexes, where if you're doing a lot of searching and a lot of stuff we were doing up here, querying XML data, XML columns, if you're doing that a lot and you notice performance issues on those columns, then you may want to think about putting an XML index on an XML data type column. Now, a couple of rules we have to follow. If we do decide we need a primary or we need an XML index at all on our XML columns, then the first thing you need to do is create a primary XML index. And this will just basically shred your XML structure and store it as an index underneath the hood. But in order to have a primary XML index, you already must have a clustered index defined on your table. So those are the rules here. If you're going to have any XML index, you need a primary one, and if you're going to have any XML index, you need to have a clustered index. Now, the primary XML index will give you a minor performance boost, but nothing major. It's just kind of a generalized index. To create a primary index, you just do a create primary XML index followed by the name of the index, the on keyword, followed by the name of the table, and then into parentheses your column or columns that you're indexing. Again, this will just simply get us a primary index, which we're going to highlight here and run on our demographic data table. So if we refresh our indexes here, there we go. We now have a primary XML index on our demographics XML column inside of that table. Now, where you're really going to get the performance boost is with your secondary XML index. And basically what we do here is we create a secondary XML index on the same column, and we tell it what primary index to use here. As you see, we reference back to our primary index. And the key here is the type of index. There's three different types of secondary XML indexes. There's path, there's value, and there's property. And you're going to basically determine this by analyzing the queries that are getting thrown against this column. If your queries are mainly xquery path queries like we're doing here in our OpenXML, this is a path query because we're just specifying to grab nodes out of a path. We're not specifying to search for specific nodes or attributes or anything like that. It's just simply a path query. Then this is what you'd want to use. You'd want to use the for path option on your secondary XML indexes. That'll speed up all of these types of queries. Now, you'll want to use the value secondary XML index if you're going to do any wildcard searching. So grabbing all the attributes out of here, for instance, if we wanted to do that, we would do something like this on our xquery, and that would be a wildcard search, which would grab all the attributes out of the customer node. Now, that doesn't work like that in OpenXML because we have another parameter to grab all the attributes here. That's why this is kind of old style. But in standard xquery syntax, you do something like this to use a wildcard here to grab all the attributes out of an XML structure. So, general rule of thumb again, filtering, wildcard searching, use value. There's also property. And property is used, you want to use this secondary XML index type if you're searching for single values. So if you're just trying to find a specific value and extract it out of an XML structure, and that's the most popular use for a column, then definitely use the property XML secondary index. So those three types of indexes, really it's just a matter of what queries are getting thrown against your XML columns to determine what type of index you would want to speed up those searches. Okay, so in this CBT Nugget, we took a big look at working with XML data. We started off there with an introduction to SQL Server XML, got you familiar with what XML is, got you familiar with the new XML data type in SQL Server 2005, and we also took a brief look at all the different technologies, tools, and SQL statements we can use to work with XML data inside of SQL Server 2005. And then got you familiar with how to create and use these XML objects. We talked about how to create XML data type columns, XML variables, work with those variables and those columns. At the end here, we took a big look at how to work with data using all the different methods of working with XML data in SQL Server. We looked at the XML data type methods, saw that the XML data type actually has methods on it that we can use to pass in xquery expressions to do everything such as query the data, modify the data, and also use that whole exist method there to see if nodes exist within a certain XML structure. We then took a look at how to manipulate data using XML DML, using that modify method, using the insert, the delete, and also there's the replace command in there. That's again called XML DML. We then took a look at how to generate XML using for XML, saw how to actually turn regular old SQL Server data into XML data. We then took a look at the opposite of that, the open XML clause there, in which we can actually take XML data and turn it into regular old SQL data. And at the end here, I just got you familiar with XML indexes. So I hope this has been informative for you, and I thank you for viewing.